This is SpaceTime Series 25, Episode 16. Coming up on SpaceTime, a new study claims that water was flowing across the Martian surface for much longer than previously thought. There's more evidence of recent volcanism on the planet Venus. And there's also more evidence of the growing war in space, with a Chinese spacecraft observed grabbing hold of another satellite and moving it into a different orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims that water was flowing across the surface of the red planet Mars for much longer than previously thought. The new data from NASA's Mars Reconnaissance orbiter spacecraft suggests that surface water left salt minerals behind as recently as 2 billion years ago. Mars was once a warm, wet world, with rivers, streams, lakes, and even a major northern hemisphere ocean. But that was billions of years ago. But as the planet's atmosphere thinned over time, the water evaporated, and Mars today is a freeze-dried desert. Now, it's commonly believed that the Martian water evaporated around 3 billion years ago. But scientists looking through 15 years of Mars Reconnaissance orbiter data have now found evidence which reduces that timeline significantly. The new research reveals signs of liquid water on the red planet as recently as 2 to 2.5 billion years ago, meaning water was flowing on Mars a billion years longer than previous estimates. The findings, reported in the journal AGU Advances, examines chloride salt deposits left behind as icy meltwater flowing across the landscape evaporated. While the shape of some valley networks already hinted that water must have flowed on Mars fairly recently, the salt deposits provide the first real mineral evidence confirming the presence of this liquid water. The discovery also raises new questions about how long microbial life would have survived on Mars if it had formed there at all. On Earth, the mantra is very simple. Wherever we find water, we find life. And so that obviously raises questions about what happens when we find liquid water beyond the Earth. For their study, the authors used the Mars Reconnaissance Orbiter's Compact Reconnaissance Imaging Spectrometer for Mars Instrument, better known as CRISM. CRISM was able to map chloride salts across the clay-rich highlands of the Martian southern hemisphere. This is the terrain pot-marked with impact craters, and these craters are key to dating the salts. See, the fewer craters a terrain has, the younger that terrain is. So by counting the number of craters in a given area of the surface, scientists can estimate its age. They found that many of the salts were in depressions once home to shallow ponds on gently sloping volcanic plains. The scientists also found winding dry channels nearby, former streams that once fed surface runoff from the occasional melting of ice or permafrost into these ponds. So the crater counting and the evidence of salts on top of volcanic terrain allowed scientists to date the deposits. Salt mineral deposits were first discovered on the red planet 14 years ago by the Mars Odyssey spacecraft, which was launched back in 2001. The Mars Reconnaissance Orbiter has much higher resolution instruments than Odyssey did. It was launched in 2005 and has been studying the salts among many other features on Mars ever since. This is SpaceTime. Still to come, new evidence of recent volcanism on Venus, and more evidence of the growing war in space, with a Chinese spacecraft observed grabbing hold of another satellite and moving it into a different orbit. All that and more still to come on SpaceTime. A new data analysis has found more evidence of recent volcanism on the planet Venus. The data, reported in the journal Geophysical Research Planets, was contained in 31-year-old observations by NASA's Magellan spacecraft. It suggests volcanic activity erupted on the Venusian surface within the last few tens of millions of years. Now that's incredibly recently in geologic timescales. It adds to a growing body of evidence that volcanoes on Venus didn't go extinct as long ago as many people had previously thought. As well as being Earth's nearest planetary neighbour, Venus is often considered Earth's sister planet. That's because they're both almost the same size with similar masses and diameters. They were both formed under similar conditions, out of the same sorts of materials, and in the same part of the solar system. In fact, Venus once excited speculation that it could provide a host for the first human colony in space. See, scientists thought that Venus's dense cloud cover meant lots of rain, sort of like a tropical rainforest here on Earth. After all, Venus is closer to the Sun than the Earth, so temperatures there are hotter, and that would mean more water evaporation, and that would mean more rain clouds. So, scientists envisaged that under its thick cloud cover, Earth's sister planet was covered in a lush green tropical rainforest, sort of like the Amazon jungle on steroids. Some, with the right degree of imagination, even speculated that tropical rainforests must have meant lots of animal life, and because rainforests seem really primitive, that must have meant dinosaurs. But we now know that if Venus is Earth's sister planet, then it's somewhat of a twisted sister. In fact, Soviet and American probes have revealed Venus to be the closest thing to hell in our solar system. For some reason, it's developed a massive runaway greenhouse effect. Its surface is scorchingly hot, with average temperatures of 462 degrees Celsius. That's hot enough to melt lead. And as for those thick, opaque planet-shrouding clouds, well, they do cause rain, but the rain isn't water. Instead, it's droplets of metal-eating sulfuric acid. Scientists have seen what look like snow caps on some of Venus's taller mountain ranges. But it turns out that snow isn't frozen water, it's actually metallic. And as for those sulfuric acid clouds, they're so heavy they crush down on Venus's rich carbon dioxide-based atmosphere, acting like the lid on a pressure cooker, and giving the entire planet a surface pressure some 92 times greater than average sea level surface pressure on Earth. Venus rotates on its axis in retrograde compared to most other planets in the solar system. In other words, the Sun rises in the west and sets in the east. But it's a really slow rotation, taking 243 Earth days to complete one revolution. And as Venus orbits the Sun in 224.7 Earth days, it means a Venusian day actually lasts longer than its year. The surface of Venus is dominated by more than 1,600 volcanic structures. That's more than any other planet in the solar system. The surface is actually 90% basalt and consists of a mosaic of volcanic lava plains, showing evidence of regular periodic resurfacing by floods of lava. It all indicates that volcanism has played a major role in shaping Venus's surface. Venus has shield volcanoes, widespread lava flows, unusual volcanoes called pancake domes, and arachnid or tick-like structures called scallop margin domes, a geological feature that's never been found on Earth. Interestingly, there's no evidence of any plate tectonic activity on Venus. In the 31 years since NASA's Magellan spacecraft entered orbit around Venus, researchers have been using the mission's radar images, topography and gravity mapping to understand the surface history of this cloud-covered world. With significantly fewer impact craters than on planets like, say, Mercury or Mars, or even the Earth's moon. And the craters that do exist are randomly scattered across the planet. Because crater numbers build up over time, Venus's low number of craters means the planet's been resurfaced over the last roughly 300 million to a billion years. Now, of course, resurfacing happens on Earth as well, but that's because of ongoing water and wind erosion and plate tectonics and volcanism. But how the resurfacing happened on Venus still remains a mystery. It's unclear if this all happened in a single catastrophic event that resurfaced the entire planet at once, randomly distributed ongoing events that systematically resurface Venus over time, or some combination of both. To understand what's happening on Venus, it's necessary to understand when Venus's volcanoes have been active. So, the question of whether Venus has had geologically recent ongoing volcanism has been an enduring enigma for the Magellan mission. The truth is, scientists still don't have a smoking gun. But there is more and more evidence suggesting a recently and potentially currently active planet. And as computers have improved, it's become possible to do more and more with Magellan's finite dataset. So, scientists used a high-resolution stereotopography dataset to look at a volcano at the edge of the 350-kilometre-wide aromatic corona. Now, coronas are another one of these strange Venusian features. They're roughly circular and are surrounded by a ring of cracks that appear, well, sort of like a crown, and are thought to actually be large surface faults. Some corona, like Aromaty, feature nearby volcanoes and lava flows. The study's lead author, Megan Russell from the Planetary Science Institute, says that instead of looking at the surface of the volcano or the lava flows, her team looked at how the volcano deformed the ground around it. You see, in response to the weight of the volcano, the ground around it bends and flexes like a plastic ruler. And we know that's the case because we see the same kind of deformation in the bending of the seafloor around the Hawaiian Islands. And from this deformation, scientists can infer properties like heat flow local to the volcano. Over time, these kinds of structures can evolve, and so the degree of deformation that's being observed can hint at how old or young a feature might be, and how much heat might be flowing under the surface. Russell says the modelling suggests that the shape and topography of this particular corona indicates that it's geologically young, and so would have similar geologically young volcanism associated with it. This report from the Planetary Science Institute.
In the 31 years since NASA's Magellan spacecraft entered orbit around Venus, researchers have been using the mission's instruments to understand the surface history of this cloud-covered world. Magellan's radars revealed a planet with very few impact craters. Since impact events should happen steadily over the millennia, this implies something wiped Venus's surface clean, either all at once or steadily over time. That something could be volcanoes.
One of the questions that's been really interesting for us is whether or not Venus has had geologically recent or ongoing volcanism, and this has been an enduring enigma from the Magellan mission. We still have no smoking gun regarding this, but there are really more and more lines of evidence that suggest a recently and potentially currently active planet.
Using a combo of new image processing techniques and only Magellan's best data, PSI's Megan Russell and Katherine Johnson used geophysics to understand the eruption history of a volcano at the edge of the 350-kilometer across aromatic corona.
So instead of looking at the surface of a volcano or volcanic flows, we look at how a particular volcano deforms the ground around it. In response to the weight of the volcano, the ground around it bends, kind of like the flexing of a plastic ruler. This same kind of deformation is seen on Earth. An example of this is the bending of the seafloor around the Hawaiian Islands. From this deformation, we can infer properties like heat flow local to the volcano.
Over time, these kinds of structures can evolve, and the degree of deformation that is observed hints at how old or young a feature might be, and how much heat might be flowing under the surface.
Previous modeling studies suggest that the shape and the topography of this corona that the volcano in our study sits on indicate that it is geologically young, and therefore we can expect it to have similarly geologically young volcanism associated with it.
Magellan's data is limited, with only 20% of Venus having the kind of Magellan data to allow this type of a study. And not all that data was equally good. Russell and Johnson were lucky to find the one corona with extremely high-quality data. Until we have more data, we can't know how common, or not, these features may be. Luckily, 3 Venus missions are planned, and we can dream of seeing this research replicated to study all of Venus's potential volcanoes in the not-too-distant future.
This is SpaceTime. Still to come, more evidence of the growing war in space with a Chinese spacecraft observed grabbing hold of a satellite and moving it into a different orbit. And America's National Reconnaissance Office has sent its latest spy satellite into orbit, a highly classified mission, and they're giving nothing away. All that and more still to come on SpaceTime. A new report claims a Chinese spacecraft has been observed grabbing hold of a satellite and moving it into a different orbit. The report was presented at a conference of the Center for Strategic and International Studies and the Secure World Foundation. The maneuver involved China's Shenzhou-21 spacecraft, approaching and then grabbing the disused Bedao G2 navigation system satellite and moving it some 3,000 kilometers above the geostationary orbit it was previously in. The Shenzhou-21 then returned to its own near geostationary orbit. The entire maneuver was observed by telescopes belonging to the commercial space awareness firm ExoAnalytic Solutions. And this isn't the first time the Shenzhou-21 has performed such a maneuver. As SpaceTime reported last year, the same satellite was observed suddenly travelling with a companion spacecraft last November, just a month after its launch. Now, at the time, the United States Space Force designated the unidentified companion object as a spent Apogee kick motor. The problem is the unidentified object remained in geostationary orbit next to the Shenzhou-21 instead of manoeuvring away in order to ensure it doesn't collide, as would be the usual protocol for a spent Apogee kick motor. And that raised speculation, suggesting that this may have in fact been an experimental payload designed to test the Shenzhou-21's ability to perform rendezvous proximity operations and manipulate other satellites. China describes the Shenzhou-21 as a space debris mitigation satellite, a nice catch-all term, but it's refused to release any details about the spacecraft or its capabilities. However, about a month before the launch of the Shenzhou-21, Beijing did display a nondescript spacecraft described as an in-orbit tanker. That spacecraft was equipped with cameras and a set of robotic arms. Now, none of this is really all that new. There's a growing list of intelligence reports about both Russian and China testing new anti-satellite technologies. Last year, another Chinese satellite was tracked deliberately maneuvering close to an American satellite, following it closely for some time and then maneuvering away again. And in November 2019, a Russian Luchno-Vimp spacecraft moved to within 1.8 kilometers of the American Intelsat 36 telecommunications satellite, remaining there for some time before moving off again. Moscow have undertaken similar satellite operations on more than 24 occasions, some going back as far as 2014 and 2015. So, it seems the battle for space is very much on. This is SpaceTime. Still to come, SpaceX launches a new classified spy satellite for the National Reconnaissance Office. And later in the science report, a new variant of the Omicron strain is now showing up globally. All that and more still to come on SpaceTime. SpaceX has launched a highly classified spy satellite for America's National Reconnaissance Office. No details of the top-secret NROL-87 mission have been released. The flight aboard a Falcon 9 rocket flew from Space Launch Complex 4E at the Vandenberg Space Force Base in California, with a core stage returning to Vandenberg, touching down on Landing Zone 4.
All systems continue to look good for an on-time liftoff. Falcon 9 is our two-stage rocket standing at 230 feet, or about 70 meters tall, roughly the height of a 20-story building. When it's fully fueled, it'll hold just over 1 million pounds of propellant that the vehicle will burn through in less than 3 minutes after liftoff. We began loading those propellants on both stages of the vehicle back at T-minus 35 minutes. The bottom two-thirds of the vehicle is the first stage. While it's designed to be reflown 10 or more times with minimal refurbishment between flights, today will be the first flight for this particular booster. At the bottom of the first stage, there are 9 Merlin engines that will get Falcon 9 off the ground and up to the thinner parts of the Earth's atmosphere. The two stages will separate from one another. The second stage continues to orbit, while the first stage makes its way back down to Earth for its landing attempt at Landing Zone 4, which is not too far from where it will lift off. If successful, this will be the first landing for this booster. It will also mark the 105th successful recovery of an orbital-class rocket. Now, as for the second stage, that will ignite its single Merlin vacuum engine, or MVAC, about 2.5 minutes into flight. It's this engine that will take the NROL-87 spacecraft to its intended orbit. At the moment, our payload today is safely enclosed inside the 17-foot diameter payload fairing. This protects the satellite from aerodynamic heating, loads, and contamination during ascent. Once we reach the vacuum of space...
Stage 1, fuel load is complete.
All right, good news there. Stage 1 fuel load has completed. Now, once we reach the vacuum of space, we'll jettison those fairing halves while the second stage continues on to orbit. Just like our Falcon 9 booster, today these fairing halves are also brand new, and we will be attempting to retrieve them from the water once they make their way back to Earth. This mission is for the National Reconnaissance Office, or NRO. The NRO is responsible for developing, acquiring, launching, and operating America's reconnaissance satellites, as well as operating associated data processing facilities in support of national security. These sophisticated systems are used to develop military targeting data, support international humanitarian relief operations, and assess the impact of natural disasters. As a reminder, per the NRO's request, we will not be showing any views from our second stage today, and we will be ending our webcast around the T+8 minute mark, just shortly after Falcon 9 touches back down at landing zone 4. So far, we are at T-5 minutes and 6 seconds, and all systems remain go for an on-time liftoff. The range remains green and ready to support. As for the weather, it's a gorgeous day for launch. We have basically 0% probability of violation with respect to weather rules for today. The vehicle and payload continue to be healthy. In fact, the payload is now on internal power. And if for some reason today that we are unable to launch, we do have a backup window tomorrow at the same time.
MD, CLD on countdown 1.
GMD, it's a MD.
Is coming through the final status check. You and your team are go for launch and landing.
MD and team are go for launch and landing.
Copy.
The clamp arms on the transporter erector, or TE, have now begun to open in preparation for retraction of the TE. This is one of the last major visual milestones that we have prior to launch. At this point in time, both the first stage and second stage are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen, or LOX, as you often hear us call it. The fuel is completely loaded on both first and second stage, and we're expecting the first stage to wrap up its LOX loading in about 15 seconds at T-3 minutes, and second stage will complete its LOX loading at T-2 minutes. At T-60 seconds, we'll hear a call out that Falcon 9 is in startup.
Stage 1, LOX load complete.
All right, so stage 1 is now fully loaded with both all of its fuel and liquid oxygen, and we're waiting for a second stage to wrap up that LOX load. When we hear the call out that Falcon 9 is in startup, that means that the rocket's autonomous internal flight computers have taken over the launch countdown. And then just inside of T-2 seconds, we will light the Merlin M1D engines and set for liftoff. Right now, the NROL-87 payload continues to be healthy on internal power, and the Falcon 9 team is tracking no issues on the rocket.
Stage 2, LOX load complete.
All right, there we heard the call out. Stage 2 LOX load is complete. At this point in time, the vehicle will start venting the liquid oxygen. The leftover liquid oxygen basically left in the load lines.
MD is go for launch.
Falcon is in startup.
There we just heard mission director is go for launch, and that the vehicle is in startup. The the onboard flight computers have taken over the launch countdown.
T-15, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of L-87. Go Falcon, go, go.
Vehicle is pitching downrange.
Nominal first stage chamber pressures.
We're now T+40 seconds into the NROL-87 mission. Falcon 9 is throttling down in preparation.
Power and telemetry.
In preparation for max Q, which will take place at T+1 minute and 12 seconds. Max Q, of course, being the moment in which the vehicle experiences the highest amount of aerodynamic pressure.
Max Q.
All right, there we heard the call out for max Q. Everything looking good with stage 1 trajectory. Now, in the next couple minutes, we have 5 events coming up in quick succession, starting with main engine cutoff, stage separation, stage 1 flip, second engine start 1, and then the boost back burn. Main engine cutoff, as the name
Start of
suggests,
chill.
we will we will shut down all 9 Merlin engines. The stages will separate. The first stage will actually flip over and conduct a boost back burn, and that's what we have to do in order to fly the booster back towards land. And of course, during that time as well, we'll have second engine start 1, where we will ignite the Merlin vacuum engine. Again, not a cloud in the sky, gorgeous liftoff from Vandenberg Space Force Base, Space Launch Complex 4 East.
First stage engine cutoff.
Stage separation confirmed.
Stage 1 boost back startup.
That first stage now is performing the boost back
Fairing
burn.
separation.
And back pull.
And there we
full
heard the
power.
call out that fairing separation has been confirmed. Unfortunately, we're unable to broadcast that at the request of our customer, but we were able to confirm the deployment of that. We're now 3 minutes into launch, and the next milestones coming up include the conclusion of the boost back burn, and that will finish at T plus 3 minutes and 15 seconds.
Stage 1 boost back shutdown.
All right, there we heard call out that the boost back burn has completed. Our first stage will be attempting a land landing in just a few moments. One of the nice things about land landings is that we're not subject to ocean weather, and it's pretty convenient to land the first stage basically right next to where it lifted off from. However, our ability to execute a land landing really is dependent upon the customer's needs. Their mission trajectory and performance needed by the satellite is what determines if we can return to land. Most of the time, their requirements don't allow for a return to launch site, which is what we're performing today, which is why we also developed the capability to land our first stages.
Both vehicles on nominal trajectory.
Good news there, both first and second stage reporting to have nominal trajectory. So that's why we developed our ability to land our first stages out in the ocean with our drone ships. Now, in order to complete today's land landing, the first stage has 2 more burns left. Next up is the entry burn, and that's where we will reignite 3 of the Merlin engines on the first stage. That will help to slow the booster down as it re-enters the upper part of the Earth's atmosphere. 4 hypersonic grid fins. We deploy those shortly after the stages separate, and those grid fins help steer the vehicle during descent. You will also see a puff of white gas. That is nitrogen gas from attitude control systems that help control the vehicle's orientation. The booster is steering itself back to Vandenberg Space Force Base.
Both vehicles are on a nominal trajectory.
So the booster is now basically coming through the thicker part of the Earth's atmosphere. So we're going to slow its velocity down with this entry burn.
Stage 1 entry burn startup.
That entry burn has begun, and this will last for another few seconds.
Stage 1 entry burn shutdown.
The vehicle continues to steer itself for a precise landing back at landing zone 4 at Vandenberg Space Force Base. The next burn we have is the landing burn. During the first stage landing burn, a single Merlin engine, the center engine, will relight and slow the vehicle down.
Stage 1 FTS is saved. Stage
Again.
2 FTS has saved.
The landing zone is pretty close to our launch pad. Shortly before the vehicle touches down,
Stage 1 landing burn startup.
landing zone coming into view for the first stage. Again, this is the first flight for this booster and first landing attempt.
Stage 1 landing leg deploy.
A picture-perfect landing of this first stage booster, its first flight and first landing. This booster will be prepared for reflight on another NRO mission later this year. This also marks our 105th overall successful recovery of an orbital class rocket, including both Falcon 9 and Heavy first stage landings.
The mission was flown into a 512.7 kilometre high sun-synchronous polar orbit. And that suggests the payload may be a next-generation electro-optical reconnaissance satellite. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.